All right, this video is going to be about radians and degrees. So in trigonometry, that's the branch of mathematics that studies relationships involving lengths and angles on triangles. So lengths, meaning side lengths, and angles of triangles. So an angle, you've seen those before, is generated by the rotation of two rays. So a ray has a starting point and then it goes on forever. So the rotation of two rays that share a fixed endpoint. So two rays that come together, they have a fixed endpoint. The initial side is the fixed ray. That's the one you start with. The terminal side is the ray that rotates away. And that's away from the initial. A positive angle is a counterclockwise rotation. And a negative angle is a clockwise rotation. I'll show you a picture in a second. An angle with its vertex at the origin and its initial side along the positive x-axis is said to be in standard position. All right, so now let's look at the pictures. So if you start at the vertex and have the initial ray on the positive x-axis, that is standard position, so starting with standard position. If your terminal side, so your rotating ray, moves this way, then you have a negative angle because you have moved in the clockwise direction. If you start here at the origin and your initial side is on the positive x-axis, so you're starting in standard position, and you rotate counterclockwise for your terminal side, then you have a positive angle. All right? If your angle stops on one of the axes, the positive y or the negative x or the negative y, you have a quadrantal angle. All right, now in the corner of your notes, I want you to go ahead and draw the two axes. Since we start over here, here's the origin, since we start here for standard position, that means that this is the first quadrant that we see, so we call that one quadrant 1. As we go around the circle, this is the second quadrant that we see, so we'll call this quadrant 2. This would be the third quadrant that we would get to, and this would be the fourth quadrant. And we always write those as Roman numerals, 1, 2, 3, 4 in Roman numerals. All right, next we have two different ways to measure angles in circles. First is degrees. This is what you're used to. A circle is divided into 360 equal degrees so that a right angle is 90 degrees. Radians, a radian measure of an angle in standard position, is defined as the length of the corresponding arc on the unit circle. Hopefully you were able to fit that all in more easily than I was. So if we consider the unit circle, a unit circle has a radius of 1. That's why it's called a unit circle. And so the equation of a unit circle, if it's centered at 0, would be x squared plus y squared equals 1. The circumference of a unit circle is 2 times pi times r. Well, the r is 1. So the circumference of a unit circle is just 2 pi. So the radian measure of an angle of 1 full revolution, or 360, is 2 pi. So that means, you can go ahead and write this in that little space, 360 degrees exactly equals 2 pi radians. They are the exact same measurement. All right. Now for the next part, if 360 degrees equals 2 pi radians, we could go ahead and divide these each by 2, and we will find on the next that 180 degrees equals just plain old pi radians. Typically, people don't actually write the word radians. They just don't put the little degree bubble that you see. So radians are usually written in terms of pi. If you have a small number that doesn't really look like it's in degrees and there's no bubble and it's like a crazy decimal, it's probably still in radians, and they just didn't write the word radians because they didn't have to, and they already multiplied the pi into the number. So that you can watch out for that. That will happen sometimes. All right, so the degree symbol is always written, just like I said. The word radians is usually omitted, usually not there. 1 radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. And that means a whole lot of nothing to you, probably, which is totally fine, because the most important part is how we convert back and forth between them, and then we'll look at that and you guys will get better at working with them. All right, so we're going to be converting back and forth between radians and degrees. And when I convert 30 degrees into radians, that means that I want to introduce a pi to the number, because in radians it has pi in it. So I'm going to start with 30 degrees. And somehow I'm going to have to be able to multiply this by a pi so I can get pi into my answer. But if I just do 30 times pi, then I'm changing what 30 equals. So if I was to multiply 30 times 1, then the answer would just be 30. And in this case, we're going to choose 1 to be pi over 180. And the reason I can choose for pi over 180 to be equal to 1 is because pi is half a circle and 180 degrees is half a circle. So technically, those are the same thing. So 30 degrees times pi over 180. In your calculator, you're going to ignore the pi because we want that to be part of our final answer. And so we're going to do 30 degrees multiplied by 1 over 180. So in your calculator, you can do 30 times 1 divided by 180, which is actually going to be the exact same thing as 30 divided by 180 degrees. So when you plug that into your calculator, 30 divided by 180 degrees, you'll get that it's a decimal. And in these, we always want to write our exact number. So turn your decimal into a fraction, and you'll get the fraction 1/6. So we're going to write 1 with a pi divided by 6. So this is 1 pi 6. It is more common for somebody to write this as pi 6. So 30 degrees is just pi 6. All right, we're going to do a similar thing for 3 pi fourths. So we'll go ahead and start off with our 3 pi fourths. Now, if we're changing it into degrees, we need to get rid of the pi symbol. So I'm going to multiply it by something that has a pi on the bottom, so that the pi here and the pi there will cancel. But if I just divide by pi, I'm changing what the number equals. So I'm going to put 180 degrees on top, because 180 degrees over pi is the same thing as just 1. Those two numbers represent the exact same thing. So 3/4 pi times 1 means that I'm going to change the way the number looks, but I'm not actually going to change what it equals or what it represents. So now I can do my pi's cancel, pi on the top and pi on the bottom cancel, and I can do 3/4 times 180 degrees. When you do 3/4 times 180 degrees, you get 135 degrees. So that might have seemed weird for now because I was explaining where everything came from, but eventually we'll get real quick at converting these back and forth in our calculators. All right, next, 2 angles in standard position are called coterminal. If they have the same terminal side. So terminal side is the ending side, or what the whole angle is, and if they're in the same spot, then you'd say they're coterminal. Angles with the same terminal side differ only in the number of revolutions. So the number of revolutions is how many times you went around the circle, which you'll see in a second. Angles differing in radian measure by multiples of 2 pi are equivalent, because that's a whole circle. Angles differing in degree measures by 360 degrees are equivalent. Every angle has infinitely many coterminal angles. Infinitely many. Sorry, that's such a small blank. So this is the next thing on the notes. Let's, off to the side, we'll go ahead and draw a picture of this. So let's say that this is the picture we're talking about, and our angle goes up about 30 degrees. So this is 30 degrees, all right? Now, if I wanted, I could continue around the circle, so going all the way around the circle, I'm at 360 right now. If I continue going past 360 to 30 degrees, I end up at the same spot, all right? So if I started, I'm going to put this back, if I started in standard position and went all the way around like this, I end up in the same spot. And so instead of being in 30 degrees, that red angle, even though it's in the exact same spot, is now at 390 degrees. It went to 360 and then went a little bit past. So those angles are coterminal because they end in the same spot, but they have different degree measures. Now if I wanted, I could go around even more times than that. So I could go around once, there's 360, 390, and then I could go down around another circle. So since I went around another circle, this would be a 750 degree angle. So that's all they mean by coterminal angles, is they're in the exact same spot, but you can go around the circle as many times as you wanted. You can also go backwards. If you go backwards around the circle, then you're going to get a negative angle. Okay, so the next thing is reference angle. A reference angle is the acute angle, so it's smaller than 90, formed by the terminal side of the given angle in the x-axis. The reference angles are always positive, and they are always less than 90 degrees. All right, so we're looking at quadrant 1 is the easiest because the angle is the reference angle. So here, the reference angle is 50 degrees. In quadrant 2, we always are looking at the x-axis and where the angle stops. So here they're saying this measures 115 degrees, which means that to add up to 360, this must be 65 degrees, and the 65 degree angle is the reference angle. Oh, they're on the next slide. All right, here, again, we always start with the x-axis. And then here's the angle down here. And so they say the whole thing is 220. And so they know that if the top half of the line is 180 degrees, then this bottom part down here must be 40 degrees. And the reference angle itself is just this part right here, just the 40 degrees. Reference angles in quadrant 4, again, we always start with the x-axis, and then we do whatever the angle the terminating side is. Now this one said 320 degrees from here to here, and so if it's 320 degrees from there to there, we know that a full circle is 360, so this part must be 40 degrees. And so our reference angle there is 40 degrees. So you notice that with the reference angle, it's always how far away you are from the x-axis, and it's always a positive angle. Those are the two things that you're going to look for.